Here we have a problem on intermediate value theorem. Okay, let's go the information. What does the intermediate value theorem say about the function f of x equals to x square positive x negative 4 on the interval, closed interval 0, 2? Okay, so to answer this question, first let's understand what is intermediate value theorem. Okay, now let's consider a function f of x on the closed interval a, b. Okay, if I want to apply intermediate value theorem for this function f of x on this closed interval, so the first condition is f of x has to be continuous on the closed interval a, b. Okay, let's say that the given function satisfies the first condition, that is the f of x is continuous on the closed interval a, b. Okay, now let's go to the second condition. To check the second condition, I have to find the value of the function at the boundary values a, b. That is, I have to find the values of f of a and f of b. So, and these two values must not be equal. This is the second condition we have for intermediate value theorem. So when both these conditions are satisfied, okay, now we can go with the next step. That is, since f of a and f of b are not equal, so there must be at least one value between f of a and f of b. So let's say that value is n. That is, f of a less than n less than f of b. So we'll have at least one value between this f of a and f of b. So I assume n is the value we have between f of a and f of b. Then there must be at least one value, say that that value is c, on the open interval a, b, so that f of c equals to this value, the value we have taken over here between f of a and f of b. So this is called intermediate value theorem. Okay, now whatever stuff I have discussed on intermediate value theorem for a function over here, the same we can apply for the function over here on the closed interval 0, 2. Okay, now first thing, the first condition for intermediate value theorem for a function is the given function has to be continuous on the given closed interval 0, 2. Yes, it is, because it's a regular polynomial function. So this function is defined for all real values of x. So this function is defined for, since it is defined for all the real values of x, it is defined on the closed interval 0, 2. So the first condition is satisfied. Now let's verify the second condition. That is, I have to find the value of the function at the boundary values 0 and 2. So that is, I have to find the value of f of 0. So f of 0 means I have to plug in x equals to 0 over here. Then I'm getting 0 square, positive 0, negative 4. So when I simplify, I'm getting negative 4. So this is a value which is less than 0. Now I have to find the value of the given function, the right side boundary value 2. So that is f of 2 equals to 2 square positive to negative 4. So the value of 2 square is 4. So then I'm getting 4 positive 2 negative 4. So this positive 4 negative 4 will cancel out. I'm getting 2 which is greater than 0. So the value of f of 0 is negative 4 and the value of f of 2 is 2. So here is negative value, here positive value. So definitely we'll have 0 between a negative value and positive value. So negative 4 is the value of f of 0. So instead of negative 4 we can write f of 0 less than 0 less than, so 2 is the value of f of 2. Instead of 2 we can write f of 2. So between f of 0 and f of 2, so there is a value 0. Then there must be a value c on the open interval 0, 2, so that f of c equals to 0. So if f of c is equal to 0 means c is the 0 of the given function. So by intermediate value theorem, there must be at least one value on the open interval 0, 2 for which the given function becomes 0. So f of x must have at least one 0 on the open interval 0, 2. So when I go over the 4 options, the correct answer choice is option B. That is, f of x must have at least one 0 in the interval 0, 2.